This will be a very basic G-code tutorial. The idea is to show you what it is, how it works, and so you can look at it, understand it, find problems, and eventually write your own. Software I'm using is Universal G-code Sender. Most of it will refer to it as UGS. It works on Macs, Linux, Windows. It's 100% free, so the guys who develop this and maintain it, much appreciated. Okay, if you come over here and click on this go button, you can select, start new, but I got this one open, so I'm not going to do that right now. You would simply name it and write G code. But I already took mine off there anyway, so. And it'll come up with a couple different options and what you're going to see here. The first being this first line. This is G20. I'm an American machinist, so we deal with inch here. Everybody outside of America will use metric, so you'd want to change this to G21 in order to use a metric system. Underneath that is G90, and this is absolute coordinate or relative coordinate mode. And what that means is, you see this yellow cone right here? This would be the WPC, the work position coordinate, or work position center, whichever way you prefer to call it. And everything written down here is simply telling the machine to rapid, to travel, to arc, whatever, to those dimensions. And that would all be based off this one point, the entire part for absolute. In relative mode, I'm not sure why you'd even use that on a CNC, but it is an option. What that does, I made a quick example here, and right here I got Z1 going down 60 thousandths into the material, and then I got G1 coming over, or G1, I got X coming over 0.200 thousandths. And you can see right underneath that, I'm telling it to G1X minus 0.200 thousandths again, but you see in this illustration, it moved over 200 thousandths and stopped because I'm in absolute mode and it can't move to 200 because it's already there. It got put in there twice. But now if you change that over to relative, G91, anytime you make changes, come up here, hit file, hit save, and then it'll update. You'll now notice that it moved the first 200 and it saw that code again because it's in relative. That now became 0 and it moved over another 200. I'm not sure why you'd want to use that on the CNC, but it's there for an option. Put that back to G90. Okay, G17. Now this by default will have G17 in there, and that's XY plane. That doesn't mean you can't move the Z or anything like that. That is primarily for arc moves. We'll touch bases on that towards the very end. If there's more in-depth people out there wanting to know more in depth about it, I'll definitely make a better tutorial on arc moves. But an arc move would be a radius between 2 points. This would be your X, this would be your Y. So if you want to do a corner radius or whatever, it would need to be on G17 to do it in the XY plane. If you want to move the Z in a radius, or like you're doing a radius on the corner edge or something like there, G18 would be for X and Z, and then G19 would be for Y axis and Z. By default is G17. And if it comes in a situation you need to change it to G18 or G19, once you're done with that specific arc move, put it back in G17, because if you come across another arc move you meant in X and Y and it's in 18 or 19, the machine will totally mess up trying to calculate that arc radius. And if you ever ran these GRBL machines, and a job, even though you ran it before, it suddenly just takes off and runs over your part, breaks your end mill, whatever. That's what they do when they get lost. When they get confused or lost, they just wreck. That's the easiest way to put it. But G17 is there by default, and that's perfectly fine until you need something else. G94, that's your unit per minute feed rate. And that's what you always see everybody in these groups saying, that, I use 36 inches per minute, or I do 914 millimeters a minute, whatever. That's what that stands for. For all the other machinists out there, there is no G95 option. I wish there was, but there's not. For those that don't know, that is telling the machine how much to move per every one revolution, and that would be off what most people don't understand is the chip load. And we'll get to that here in a little bit. Underneath that is M3, which simply tells the spindle to turn on. Then there's an S value. The S is simply the speed you want it at. For this particular example, I'm using 18,000. I got a VFD strapped on that machine. The tool I'm using is a 2-flute, 1/8" end mill, flat tip. I'm using a 1,000th chip load for milling and an 8/10,000th chip load for plunge. And that's when people ask you what feed you're using, you should always list chip load. And the reason for that is your inches per minute or millimeters a minute is a sum of 3 variables. You got the number of flutes, that's the little edges that cut on the end mill. You got the chip load, which is actually what you're feeding. That's the amount of material one edge takes off what you're cutting per one revolution of the spindle. And of course, the last one is your RPM. So if any one of those 3 variables are different, then your feed rate will be different, and often drastically. Like I said, I'm using 18,000th, 1,000 chip load, 2-flute end mill. So that would be 36 inches per minute or 914.4 millimeters a minute straight running. Now, if that was a 4-flute, that would be 72, or a little over 18,000 millimeters a minute. If that was a single flute, then that'd be 18 and a little over 450 millimeters a minute. So any one of those variables change, the inches per minute or millimeters a minute will change, and often drastically. So that's why you shouldn't give that for an example in these groups. This is primarily for a Jimitsu users group on Facebook, but this goes to all Gribble machines, or GRBL. That's just a quick example of how to set your RPM. Wood FFM, the surface feet a minute, is 400 through 800 for hardwood, 600 being nominal, and then softwood is 600 through 1,000. And the calculation for that, simply the FFM number. In this case, I use 600 times 3.82 equals 2292. Then you divide it by the tool's diameter. I'm using an 1/8 inch. That's 0.125. Gives you 18,336. You don't have to be exact. 4 to 800, 400 is going to be a little over 12,000. 800 is going to be a little over 24,000. So you have a vast range. If your wood's really hard, you notice a lot of heat, you can smell the wood getting hot, slow that RPM down. If you're getting, I guess you call it fuzzies or whatever on the softer wood or whatever, and it's cutting fine, speed that RPM up. You get a better surface finish. You just got to play with it a little bit. It's always a vast range. Now for the actual feeding on this, one thing you can do when you come down here, if you put a coal in the front of it, see how it grays out. Well, now it's pretty much worthless. As far as the machine is concerned, it won't read it. I don't even think the Gcode Center will send that data to it. It has to be highlighted, like your GO here, XO, YO. I have a couple different things set up ready to rock and roll here. And make those changes, save this real quick so it'll update over here in the visualizer. Okay, so we understand this, and yes, I got it back in absolute coordinate. And this is simply a 4-inch by 4-inch box. Think of a contour. And since it's only one time around, it's at the depth that I set it at, which is 60 thousandths. Okay. Now on these machines, GO is rapid, meaning you tell GO it's going to travel at the firmware set rapid speed wherever it goes. It's normally not ideal, like you see here where I got my Z. I stopped the Z 100 thousandths above the workpiece. You can run that down to 0, but oftentimes you'll get like a little nudge into it or whatever. And that's not the best on the tooling. Or, if you touch off the top, and this side over here, because you ain't machined it yet, it's a little bit higher where you just wrap it into the part. You can damage tooling and whatnot. So it's always a good idea to leave the Z above when you're doing rapid. G1 or GO1 is your feed. And anytime you put that in there, it's going to do just that. It's going to feed at the speeds that you allocate. You have to allocate a feed. Like here, I'm using 36 inches a minute. Okay, and right there is telling it X0, Y2. This red line right here, that's your X. This green line right here, that's your Y. You have to excuse me. I get a day off work for Thanksgiving, and of course, I got a head cold, so bear with me. Right here, we can see X0, Y2. The WPC is dead center of this part. So 2 inches up on the Y and 0 on the X. Here, I'm going to feed the Z in. I slowed the Z down a little bit for the plunge. Going in 60 thousandths, almost a 16th. Now, the next thing it's told to do, because my tool is sitting right here. I should be able to illustrate that. Yeah. Feeds in. Now, the next thing is going to feed over to the right side of this box and simply down. See, it was +2. And even though there's only a 2 on there, is -2. So remember, this is 0 for the Y. So +2 here, and then -2 here for a total of 4 inches. And then the same thing for the X. We go from +2 on the X to -2, which is a 4-inch travel. Y is going from -2 to +2 with a 4-inch travel. And since this was started with X in the center, it's told back over to X. You can see that line highlighted right here. And of course, Z comes up and clears the part, 100,000. That would be, I guess, a 60 thousandths deep contour for where you're going around. You could simply go in here, admit that line right here where it's retracting out, but you could go here, hit this, copy, paste as many times as you needed by incrementing. Like this is 60 thousandths, then I would change that to 120, then 180, until I got through the thickness of whatever it was I was cutting that contour out of. Now the biggest problem you're going to have here in the finished part would be where it comes right here and feeds in. We got back over here, it's traveling over, gets up there and it feeds down. And if you ever machine one of these parts, you notice there's a radius left over from your end mill because it's feeding in on the side. It vibrates a little bit and it undercuts it. So now you got to sand this out of it. The easiest solution for that is simply not feed it in straight down there. And the most common thing would be to take it back away from any finished machining surface to feed it in, so when it does inevitably vibrate a little bit going in, it doesn't harm anything. And by the way, I hope you guys are all having a good Thanksgiving, for those who celebrate it anyways. Now, over here, this is the same box, same 2 inch. All these are going to be the same 2 inch or 4 inch and 4 inch, 2 inch per axis, plus and minus side. The only difference is I brought X all the way over to 2 1/4 inches past the side of this box. And then it's going to feed down. And then take across and finish up that box shape. Lift the up out the way. So now you no longer have that indent from the tool. And this is normally the go-to for feeding, plunge feeding in tools. But unfortunately, there's often times where you have geometry and whatnot where that's not an option. So the next option is to ramp it in. And then when you're writing Gcode, you notice like these first 2 lines. This is a GO, which is a rapid movement, and then a G1. Just like if you notice the feed rate offer to the side, there's one feed rate of 32 where it's feeding the Z in, and actually feeding the Z down. And then all X and Y movements and all that are at a faster rate. And you don't see that F36 every line down there because GRBO will know that unless you physically tell it to change that feed rate, which is by the F, then it will use what has been using that whole time. And G1 and GO are technically the same way, but I always have people always put G1, GO every line so it becomes habit. Because when you start doing arcs, and you will use arcs a lot if you do any manual G coding, and even if you're trying to read a G code, you're going to see G2, G3 on a regular basis. We'll get into those later. So it's always good practice to always write G1, GO, whatever, every line. You don't have to, but it's good practice to do. You can to feed rate too, it won't hurt anything. Just there's not really a scenario that really complicates any other factor. With, I guess, maybe the exception, you wanted to slow it down, you didn't. Man, if you forgot to slow that line down, even if you're putting F in it every time, that wouldn't make any difference. You can see here again, that's rapid. And this time, it's kind of hard seeing these lines once in a while. You can see it's just rapiding over here to this position. GO. There's G1 and Z10. And you know what? I never saved this. I'm going to say that's not actually right. Hey, looky there. We got something different on the screen. Anytime you change that, hit save, so it updates the visualizer. Okay. Now it's rapiding over, but you notice I'm on the finished size of the block. Because in this scenario, we don't have a safe place that we can plunge that end mill down into and it not do that little radius cut into the finished part we want. This is where a ramp comes in. You can start it on the exact top if you want. I normally start it about 10 thousandths or so above it, and that's this line. I'm feeding it down to 10 thousandths above 0, which would be the top work surface of my part. Then I feed it over on the X. Right now we're at -2 on the X. Remember, this here is 0 for X. This would be negative, and this would be positive. Right now it's -2, it's right up here. And it's going to feed over to 0 on the X. And the Z is told to come down 60,000. So the whole time it's feeding over, it's lowering that Z down. And Gerbil, if you tell a Z movement with an X or whatever like that, it's going to do it evenly. So it's going to take 2 inches for that tool to reach 0. Or 0. It's good to reach what we tell it, which is -60. Then it's pretty much the same as the others. It goes +2. We go Y from +2 to -2, which is 4 inches. We take X, which was +2, and now we're telling it to go to -2, which is again 4-inch travel. And then Y, that was -2 up to +2. Now X, we're going to 5. And the reason was that this got finished going to -60 on the Z at 0. But if you overlap it a little bit, you're just guaranteed to clean up any bounce or any overlap that tool might have had, and then feeds back up out the way. That just ensures the face of it when you get cutting with it. When you do that, you'll notice a little spot right there if you don't go back over and travel across it. That just cleans that up. Now, of course, for those that have any experience with forever, you know that my box has been 4-inch by 4-inch by 4-inch by 4-inch every side. Well, the problem is I'm using an 1/8-inch tool, and if I wanted my box to be 4 inches, that line that we're drawing in this G-code is the center line of the spindle. So an 1/8-inch end mill, a 1/16 of that would be cutting past that 4-inch on this side, this side, this side, this side, effectively making my box an overall of 8 inch smaller on both axes. So instead of 4-inch by 4-inch, it'd be 3 7/8 by 3 7/8. So this is where tool offsets come from. And again, if you're a programmer, no, GRBL does not use G40 or any type of tool size or compensation at all. So everything has to be calculated into the G code. And where this example is, you see it's an 1/8 inch, so half of that would be a 1/16. I hate that little dot thing that comes up on here. Probably setting in there to turn that off. And I did the same ramp in that we did previously, just with corrected dimensions. Instead of 2 inch, now it's a 1/16 wider. Instead of 2 inches, it's a 1/16 taller. And then overall same process that the last example was. Feeds over, feeds down to my wanted start point, 10 thousandths above, feed rate of 32 inches a minute. It's feeding again. It's going to X0, Z minus 60. When you touch the top of your part, a positive number will be up away from your part. A negative number will be below the top of your part. I'm not sure if I explained that. F36, 36 inches a minute. And then it's basically the same path. Just everything on here got opened up a 1/16 to accommodate for the tool. And that brings me to my next time. This won't always work because an 1/8 inch tool is a standardized size, but if you put an OD mic on it or whatnot, you'll find out an 1/8 inch tool can vary 5, 10, 20 thousandths. So you would have to, like, you first get a tool, you'd run a size to something critical, measure it, and then you have to compensate for that. Now, if you're using CAM software, you can go to that tool data and simply change that tool data's size to what you're getting. Otherwise, you have to go in here to the Gcode and add or subtract from the finished dimensions here. Like if it was a 1,000th, then you would take that to 61.5 instead of 625, etc. And that's all pretty much the same as before. And just straight lines. Anything, as long as it's G1, you're feeding into the part. We can be Geo2, but that's a rapid. G1, and you tell the coordinate, like if you come over here 1 inch and Y 1 inch, that's 45 degrees, 1 to 1. You know, and if you're starting at 0, it would draw a 45-degree line straight up to that point. I do recommend you get UGS, put it on there, and start playing with it, and you'll see. Now, as you notice, the visualizer doesn't update as soon as you make a change. You have to click up, come up here, click File, click Save, and then the visualizer will show it. Now the part that can be confusing, so I'm going to show you the easy part first, and that will be the R method to do an arc, or a radius rather. A lot of you are going to see that and think, man, that's so much better than the IJK or whatever, which will be the next method I'll show you here in a minute. The problem with R is if you have a GRBL machine that's only an 8-bit, Gerbil themselves tell you don't use R at all. And then if you get in a more complex shape, like say you're doing a helix bore cycle or something like that, or a threading cycle or whatever, if you use R, odds are good the machine's going to get lost, it's going to take off, now you just broke the thread tool or your end mill that you're helix boring with or something like that. So for simple corners, like on this one box contour, that's okay. Even then, if I was writing a Gcode, I still wouldn't use it simply because I'm just used to IJK. But IJK fully defines how you want that radius. And like R, you can't use it to do a full circle, where IJK you can. The start and end points are the same, and you'd simply set it with I or J or whatever to make the circle on the side you want. And while that is possible, just like it's possible to use R, I'm going to tell you right now, you should never do more than half of a radius. Or a half of a radius. Half, 90 degrees, if I could talk. So it'd actually be a quarter. The reason for that is once you exceed 90 degrees, like you do 165 or 250, or you do the full 360 degrees, it's possible to have more than one calculation. Because while it fits this way, the one you want it, it can also mathematically fit a different way you don't want it. And as soon as it realizes there's not a definite answer, GRBL again will get lost and just mow your part down. So 90 degrees max, you can do less, but 90 degrees max is ideal, and IJK. But I know we got a lot of lathe guys in here that's used to using R. For something as simple as this, you could use R and be perfectly fine. Lathes don't have complicated arc moves on them because the part's turning. That's not really an issue. Mill guys would be able to tell you, that's what these are. These desktop CNCs are just baby mills. Actually, here this is basically the same as this one. It's offset for the tool width. Just instead of having the square corners, we got these radiuses here. Now these are 3/8 radius. Let's get up here to a move point. That's speeding over, that's speeding down to start. That's to ramp in. Now you notice here, I stopped at 375,000 shy of 2" because that's where the beginning of my radius is going to start. Come down here. Now this here, you notice, doesn't really match anything. This is G2. G2 is an arc move. G2 is clockwise. G3 is counterclockwise. So it depends which way you want to move. Okay, now, since I told it this point here, which is 16875, the line above it, this one right here, that one's finished point. Now G2, you tell it the finish points. Now see, X is now all the way over here to 2 1/16, and Y is 16875 here. And just put that radius, the R value, the radius in there, and it draws that. There's not really any other calculation that could fall into that with the R value. It's defined, it's fine. Would I normally use it? No, that's just out of habit. But situations like this, there's no reasons why you can't use it. According to Gerbil, it is supported. Again, only if you have 32-bit boards. The 8-bit boards, I don't recommend using it at all. And this is the same thing over and over. Since my WPC is a dead center, and this is a box, all sides are equal. So the only thing you're really changing is this is plus, this is plus, this is minus, this is minus. The numbers are basically the same, just plus and minus for their corresponding sides. To better illustrate that, y-axis right here, this would be +2 on y, well actually +2 1/16 on y, and -2 1/16 on y. For x-axis, this would be +2 1/16, and that would be -2 1/16. And then, so like this is X and Y, so the G17 is the most common one. That's exactly what you need, so you don't have to change anything. If this would have been with the Z-axis, we would have had to have changed to a G18 or a G19, and then I just would have put it back to G17 once that process was done. And I'm sure I said it already. If not, you can figure it out. Anything you put this little semicolon in front to, it will completely ignore. So now here I tell you, doing it with I and J. Each axis has its own. I is for X, J is for Y, and K is for Z. You got to make sure that way it knows when you're doing this which axis is the one that the center of the arc is off of. And I do recommend notes. You notice every one of these little block deals are notes. This is very, very basic Gcode, obviously. So you get in the complex machine and all that stuff, this Gcode could easily be 1,000+ lines long. You want to be easily scroll to it, find it is the section you need to work on. And there you go. Okay, this is basically the exact same Gcode that's up here, with the exception is we're replacing R with I and J. And again, I is X, J is Y. we follow along this. We get down here with stop point. We're fixing to do that first radius. Okay, the easiest way to remember this is the radius is coming for the y-axis, so that's going to be j. And remember, this is plus, this is plus, this is minus, this is minus. And we're wanting to turn that to the minus side. So that would be 375 minus 375. And that's what I got right here. And a straight shot. And we're down here on this one. Now this we're swinging over to the x. So this is going to be on the I. And again, this is facing towards the negative side. So that would be negative 375 on the x-axis, or the I. J would be 0. Come down here to the other side, we're again bending it on the y-axis, but this time we're pointing up, pointing towards the positive. So you notice here, I is 0 because we're on the y-axis is bending, or I guess curving. And you notice I now have a positive 375. The 375 is the actual corner radius, and positive because of the direction we want. And then finally, the top one here, same thing. We're back over on the x-axis. We came here, and now we're taking the x-axis radius over, so that's going to be there, and the x is pointing towards positive, so it's going to be positive. I for x, positive 375. Like I said, you can use R here if you got a 32-bit board, but if there's any want for it whatsoever, I'll start doing the helix boards and everything, and that's where you're going to have to use I and J, or you're going to wind up having your machine run away on you. They can only calculate so fast, and the helix bore is nothing but just continuous arcs feeding down at the same time to, say, bore a 3/4 inch hole with an 1/8 inch end mill or something. Oh, I don't know if I'm going to waste time with that. No. Yeah, give me a minute. I'm almost done here. Okay. Sorry about that. These here were just examples for using X and Z, and I was going to go through it, but I'm not going to do that because that's already getting into more complex areas. There's stuff in the center we haven't even touched yet. Now, this is already getting kind of long, so I think I'm going to stop this here. I do highly recommend that you get Uggs, it's free, and start playing with this. And you'll see what I mean, your G1s, your GOs. If you want to start playing with the G2, G3s, just remember G2 is clockwise. If I wanted to go up and be counterclockwise, I would use a G3 instead of a G2. You can use R all you want, but I highly suggest if you're going to do any manual G coding, or even want to read a lot of G code, like your CAM software is not going to use R, it's going to use I and J, I, J, and K. That way, if there is a problem, you come down here and look, because if any of these numbers aren't 100% locked in, like there's a mathematical error, it rounded or something like that, it can and will confuse the machine. As the machine gets confused, unfortunately, I think all of us have seen it at least once. It just takes off, mows over your part. Any questions or comments, feel free to ask them, and I'll answer them as they come.